Here we have Sia, June 2015, higher paper, question 7, resistors. So it's 4 resistors connected between X and Y are showing below. We've got different switches here. We can open them to stop the electricity from flowing or close them to allow it to flow through. So it says complete the table to show the effective resistance between X and Y for the different switch settings. So our first one, A is open, so it's not going to be able to flow through here, and B is open, so it cannot flow through here. So that means it can only flow straight through. So looking at these resistors, the 6 and the 3, it's the only resistors that will flow through. They're in series, and in series, the total resistance is just the sum of the individual resistors. So it's fairly easy. It is just 6 plus 3 and we get 9. Okay, now we're closing switch A and switch B is then open, so electricity cannot flow through here. It is going to flow through here though, and here. So this bit here we're looking at is parallel, and in parallel we have our two formulas. You pick one. We have 1 over total resistance equals 1 over R1 plus 1 over R2, or the product that's being multiplied. The resistors being multiplied divided by them resistances added together. So I'm just going to do it here over to this side. So it is 1 over 12 plus 1 over 6. My writing's fantastic. This 1 divided by 12 plus over 6. Okay, that is equal to a quarter. So my 1 over RT equals a quarter. I don't want 1 over RT, I want RT, so I flip that. So it becomes RT is equal to 4. Now 4 is not my answer because this is only for this part here. So my resistance when I'm just traveling through these two is 4. So we can pretend that the 3 is in parallel with this new resistance of 4. So it's 4 plus 3, which gives us 7. Last one, we have switch A open, switch B closed. So it can't flow through here, but it will flow through the 6 and it will flow through the 4. Again, the 6 and the 4, they're in parallel, so we'll quickly do the wee parallel. Feel free to use the other equation, you will get the same answer. But due to lack of space, I'm only just doing the one example here. Okay, and that is equal to, it's 5 over 12. Okay, so my 1 over RT equals 5 over 12. I don't want 1 over RT, I want the total resistance, so I have to turn this upside down. So it's RT equals 12 over 5, which will equal to 2.4. So my resistance of this part here is 2.4, so I can pretend that I've gotten rid of these two and I just have this resistance in series with this of 2.4. So it's 2.4 plus 3, so remember we're going from X to Y here, and it is 5.4. Okay, now the next one is calculate the total resistance between X and Y when both switches are closed. Okay, so here that's closed and that's closed. So electricity can flow through all 3 paths, and it's obviously going to come out, join together back here and come out here. So we'll leave this one for the minute. We're going to look at these 3. These are in parallel, they've all got different values, so we have to use our resistance in parallel equation, this one. So remember, you need to show you're working out and write your equation, or you will not get your full marks. I can call whatever one I want, R1, R2, R3. So it's 12, 6 and 4. So it's plus 1 over 12 plus 1 over 6 plus 1 over 4. Type that in to my calculator. It's useful if you know how to work the fraction button on your calculator. It just saves some time. So that equals to half. So I have 1 over the total resistance equals a half. I don't want 1 over the total resistance, I want the total resistance, so I turn this upside down. So RT equals 2 over 1, which equals to 2. Okay, so this whole thing here is 2 ohms. So we're pretend that that's been taken away, been replaced with a resistor of 2 ohms that's in series with this. So my total resistance overall, so here I'm just drawing my 2, that's my resistance of those 3, and it's now series with the 3 ohms. In series, our rule is that we just simply add the resistor values together. And it's very, very simple. It's 2 plus 3, so RT overall equals 2 plus 3, which is equal to 5. And that's your 4 marks.